Good morning. Myself is B. Raghuram Singh, working as a scientist D in CWPRS Pune. The topic of my lecture is Introduction to Hydraulic Modeling for River Engineering. So the topics under consideration are fundamentals of river engineering and introduction to modeling. So before going to learn about the physical modeling or hydraulic modeling, one should know about the riverine structure, the total river system from its origin to its confluence with sea. So rivers are formed along the defined channels to drain the water obtained by the way of precipitation and melting of snow from high altitudes. Here you see, so river is originating at the in the hills and flowing from um, flowing with high velocities and deep slopes and reaching to the foothills of the foothills of these hills, and there it will spread. These two uh, reaches we will call as upper course. In this upper course, the steep slopes are there, and the foothill slopes will reduce, and suddenly it will flatten. After that, river will enter into the alluvial plain. Here, river will behave meandering and bleeding pattern. After that, river will enter into the sea. Before entering into the sea, it will called as a deltaic river. Here, the main river is divided into number of channels before it going to the merge to the sea. And along with water, this uh, river is also carrying sediment to the river discharge, and this sediment is uh, coming in from the catchment area and eroding of the banks and the beds. Here you can see the total river network. Here the the precipitation which is occurred in the catchment area, it is coming to the river by a runoff through the small channels and like tributaries and entering into the main river, and it is contributing discharge to the whole river. So from its starting to its confluence, the total discharge is depending upon the total tributaries of the main river. The topics under consideration are fundamentals of river engineering. In this river behavior, just now explained about the hilly region, floodplain, delta. These are the three rivers and types of river: Himalayan and non-Himalayan rivers, flashy rivers and virgin rivers. And river pattern, straight river pattern, braided pattern, meandering pattern, and oxbow lake pattern. And after that, introduction to the modeling. So river types and their behavior we can discuss here. Two sources of water flowing in the riverine system. The first one is tidal water discharge. Just now explained about the deltaic rivers. In these rivers, the tidal effect is also there. The water entering into the rivers by the tidal effect. At the same time, the main freshet discharge is also coming from the river from its upstream. So both just now engineers have told about the Kalpasar project. In this model, we have designed both this tidal effect at the same time the main discharge also. So this is the tidal rivers, and while coming to the freshwater discharges, precipitation is the main source of this discharge, and snow melting is also one of the uh, source of the discharges. Fresh waters entering the rivers from the upper ends are also derived from the sea, but by the different process like water cycle. The supply of fresh water is, however, variable and intermittent. Type river types and their behavior. River reaches, just now I explained upper reaches and middle reach and end reach. In upper reaches, hilly region and submonante region, and middle reach, floodplain, these alluvial rivers, end reach, delta zone. In upper reaches, the hill reach, that is inside rivers, narrow deep valley, they are flowing through this narrow deep valley, and channel is formed due to erosion and sediment transport. Slopes are very steep. Bed material is rocky bed, large size rocks you can find out in these rivers. Flash flow, swiftness in the flow. Flash flood means sudden rise of uh, hydrograph. The higher discharge within the small time period it will occur. It is due to the cloud burst in the local catchment. So nowadays it will be happening in Hyderabad and all over the India. In earlier days it will be happening in the only hilly regions. So formation of rapid turbulence along their courses. They do not present a regular pattern of meandering because of varying resistance of bed and banks to erosion, which vary along their lengths. These are the rocky rivers, rocky strata rivers, and here the slope is very high, and the bed is with rocks, and flow is will swiftness is there, so it will be meander. One day it will be there, and next day there it will be not there. Like that, the profile is like that in this rocky rivers. And while coming to the this foothill of rivers, river characteristics are steep source are also like that only. Bed material is mixed with boulders, gravel, shingle and sand, and regular meandering courses, deep well defined beds, wide floodplains we can find out in these boundary rivers. So straight courses are there, and wide shallow beds you can find out in these boundary rivers. Channel will be shifting, braided and interlaced types. You can find any type of beds. During flood, rise, high velocity, transport bed material. When flood recedes, lowering the velocity and bed material will materials pile in heaps. Due to this only the braided pattern will happen. Channel wandering caused because of obstruction, reduced velocity, new direction of river flow, attacking banks and widening beds. These are the two rivers in upper reaches. You can see the diagrams of these border rivers and rocky strata rivers in these pictures. After that, the river enters into the alluvial plain. So here, the erosion is taking place. So erosion is taking place on the concave bank, and the material which is deposited on the convex bank. So transport sediment similar to the bed material in these alluvial plains. Deposition along convex sides of successive beds. The erosion of banks, the part of bed load movement and the location of deposits change significantly with change in stage. Rivers in floodplain are further classified as aggrading and degrading or stable. These are the other three types of rivers in alluvial plains. Aggrading means the bed of the river is aggrading year by year. The bed levels are rising. River built its bed because of sediment deposition. Due to sediment deposition from the upper reaches, and it will be deposited in the alluvial plains, so the bed is rising. This is due to the obstruction of the hydraulic structure. Upstream of hydraulic structure, you can find this type of rivers. While coming to the degrading rivers, the bed is covering and year by year, day by day, and the bed cover occurs and bed erosion will occur, and the degrading type of rivers will appear like this in the downstream of hydraulic structures. So this type of rivers are called degrading rivers. Stable rivers are this type of rivers are non-covering, non-silting property they are following. So the silt which is coming into the stream or river is same as the going from the stream. So these are the three types of river: aggrading, degrading, stable in alluvial rivers. And aggrading type of rivers, the heavy material sediments received in this one characteristics. Existing structures causes water level rise and flattering the slope. Extension of the delta at the river mouth. Sudden intrusion of sediment from the tributaries. A sudden intrusion of sediment from the tributary also cause the aggrading type of river. Straight and wide reaches, shoals shift with flood, flow divided into number of braided channels. In this case, the flow divided into number of channels, that is called a braided pattern. Here you can see in this picture. Degrading also, this type of river is formed either by cutoff above the cutoff, upstream of cutoff, or below a dam or barrage. These results respectively in sudden lowering of water surface upstream of the cutoff, which increases slope, and the sudden diminution of its sediment load. Here you see in this diagram, here degrading river you can see in this one, and this is the balanced one, and this is the aggrading river type, stable type. This is non-covering, non-silting rivers like Tapi, and the last one is tidal and deltaic rivers. The whenever river enter into the sea, before going to enter into the sea, it will be divided into number of channel, and periodic changes in water level occur due to tides. Before becoming tidal, a river may split into branches and form a delta. It will form a delta. A periodical rise and fall in the level depending upon the nature of the tide. Tidal effect depends on the slope of the river, the tidal range, pressure discharge, the discharge which is coming from the upstream of a river, configuration of the river. All these tidal effects depending upon the discharge of these tidal rivers. This is the river Gaga before it confluence with sea. It will divide into Hooghly and river Padma. And the other classification is Himalayan rivers and non-Himalayan rivers. Water melt, water from melting snow and rains. These are the perennial rivers. Heavy sediment load will they are carrying, and fragile rock is the bed material. Non-Himalayan rivers are depending upon the precipitation of rainfall only. Aravali, Vindhya, Satpura, Sahyadri ranges are the they are originating in these ranges. Less sediment yield and stable bed. Flashy rivers rise and fall of flood are sudden, all of sudden, and flood hydrograph are steep. Rise and falls is of very short period of 1 to 2 days. Virgin rivers are rivers. They are dry up before delta. They are originating at one place and flowing up to some distance and they are vanish. These are the river. This type of rivers you can find out in Gujarat and Rajasthan. This is the flashy river you see. Sudden discharge will enter into the river. The discharge is also very high within short period, and it will be disappearing with short period. And here Virgin River, you can see this figure. River will originating at one place and suddenly disappear, and it is not going to confluence with the other rivers or sea. These are different types of river, straight channels, braided channels. I have explained. These are the pictures of braided channels. Meandering also one of the characteristic of river. Flow winding course shift due to local erosion and rebuilding banks. Sinusoidal curve we can find out in this meandering pattern of rivers. This is the example of meandering channel. This is Oxbow Lake river channel. The river will follow a river Oxbow Lake type flow. After sometimes the, the deposition will take place in these two locations, and a straight channel will be formed and flow will be like this. So these type of uh, meandering effects also we can see in this river pattern. Now I am going to explain about the physical and mathematical modeling of rivers. Before going to modeling, just now I explained about the different types of river, because the whatever works or whatever structures studies we have to conduct, we can know about the river and the bed material of the river and the flow and the location of the river and what type of bed material slopes and all these characteristics you should know before modeling. So number of complex factors involved in the design hydraulic structure. Adequate answers to various problems cannot be obtained by analytical methods. The designer will design only the hydraulic structure, but he doesn't know the how it works after its construction. In the model studies, we are constructing a small replica of the hydraulic structures and we are relieving the water. Suppose three discharges like 25 years return flood, maximum flood, and 50 years flood and 100 years flood, and we will check the all the hydraulic parameters and the flow conditions nearby the hydraulic structures, and we suggest the design parameters and bank protection works, river training works near the hydraulic structures. The models therefore become a handy tool for such studies. Two types of models, namely physical model studies and mathematical model studies, we are conducting in CWPRS. Physical models are used if the physical phenomena can be reproduced with the sufficient similarity by reproducing the length dimensions of the real problem area. Mathematical models are used if the hydraulic phenomena of the problem can be described mathematically with sufficient details. Both physical as well as mathematical models are based on certain assumptions and limitations. The area of study. Various types of hydraulic phenomena are studied with model studies such as flow across rivers, barrages. Also, we are studying barrages and sluices. These are the hydraulic model studies which we are conducting in CWPRS in various divisions. Bridge piers, viscous turbulent flow through pipes, open channel flows, non-uniform flows, backwater curves, sediment transport and transport of pollutants, wave motion and wave action, tidal flow, density currents, air entrainment of and water hammer, etc. These type of studies we are doing as physical model studies in CWPRS by using the data which is given by the project authorities. The phase of study is first modeling. The first we have to construct a model by using the parameters, the drawings, detailed drawings of this hydraulic structure. After that construction, we have to calibrate or validate the model by using the data which is given by the project authority. So known discharge or water level data we are using for the calibration of model. After that verification, other data similar other data also we have to use for verification. The model is working properly or not. With that type of verification also done before going to the model studies. In model studies, we are doing study flow analysis and unstudy flow analysis also we are conducting at CWPRS. Model calibration and verification. Calibration of the model implies adjusting the model by corresponding results from the prototype measurements in such a way that the model data and results fit to the prototype data and measurements with desired accuracy. After calibration, it is assumed that the model is responding a specific and known situation in the prototype satisfactorily. Verification of the model implies running the model for another known situation without adjusting the model parameters. In fact, verification is a must because calibration alone is not a sufficient guarantee for reliability. So calibration and verification is very much important in modeling of rivers. In some cases, calibration and verification are not possible because the prototype does not exist. It is then advisable to carry out measurements on existing similar structures. Experience in modeling is gained if the model results are later checked in the prototype. After checking the prototype, we can gain the experience of the modeling. Dimensional analysis. So before model studies, we should know about the dimensional analysis. The dimensional analysis has a wider use for the fruitful application for scale models. The scales of the various parameters can be determined from the mutual relations of these parameters expressed in the dimensionless products, Reynolds number, Froude number. Generally, we are in open. We are river engineering problems. We are considered as open channel. So Froude number is predominating in this studies. So we are considering the Froude number as a basic parameter for this river modeling. In the studies of river engineering, the flow is considered an open channel, so Froude number is predominated and considered for model studies. In hydraulic engineering, there are usually three elementary quantities: mass, length, and time. MLT we know, dimensional analysis. Using these three fundamental dimensions, relationship between various hydraulic parameters can transfer into dimensionless forms. Here I am explaining about the hydraulic models. There are different types of models we are constructing in CWPRS. Geometrically similar model means the both horizontal and vertical scales are same, only one scale, like 1 is to 80 for horizontal and for vertical. A close dynamic similarity in case of hydraulic forces like flow conditions, velocity, and acceleration. Forces involved in etc. is possible in a geometrically similar model. So distorted models are there. In the distorted models, we are distorting the horizontal scale and vertical scale. Horizontal scale is different and vertical scale is different. And in this geometrical scale, both scales are same. So real representation we are doing by geometrically similar models. While coming to the distorted models, uh, in this geometrically similar model, we are using for spillway models, siphon models, ship movements, harbor backwater models are generally geometrically similar model. You see here a typical photograph of geometrically similar rigid bed model, and this is the distorted model, mobile bed model. Vertically distorted models. Vertical distortion is necessary for one or more of the following reasons. When size of the stream reduces, relative depth increases with reference to the width. This is the way of nature to maintain necessary turbulence in the stream. To maintain the necessary turbulence in the stream, we have to distort the model. So this is the distortion. In the same way, turbulent flow, similar to prototype, is maintained in the model with vertical distortion. Turbulence flow is also maintained by vertical distortion. If you take same scale, geometrically similar, then width is more, some depth is less, then we can't maintain the turbulence in flow. So due to that, we have to go for distorted models. Hydraulic forces are scaled down with the model scales. Therefore, bed movement cannot take place similar to prototype unless large model with small scales are made. Some of the distorted models I will show here. Vertically distorted models we have constructed in CWPRS. The Kosi River model. The horizontal scale is 1 is to 500 and vertical scale is 1 is to 70. The distortion is 7.1. Ganga River is 1 is to 500 and vertical scale is 1 is to 70 and vertical distortion is 7.1. Yamuna River still within we are running now also in CWPRS. You can visit the Yamuna River CWPRS. The horizontal scale is 1 is to 300 and vertical scale is 1 is to 60 and vertical distortion is 5. Brahmaputra River model 1 is to 500 and vertical scale is 1 is to 60 and the vertical distortion is 7.6. Brahmani River, the horizontal scale is 1 is to 350 and vertical scale is 1 is to 70 and vertical distortion is 5. Like that, Tapi 1 is to 330 and vertical scale is 1 is to 72 and vertical distortion is 4.6. Gandak River model is horizontal scale is 1 is to 200 and vertical scale is 1 is to 30 and distortion is 6.7. Narmada River is horizontal scale is 1 is to 330 and vertical scale is 1 is to 50 and vertical distortion is 6.6. Mahanadi River is 1 is to 400 horizontal scale and vertical scale is 1 is to 66 and vertical distortion is 6.1. Satluj River is 1 is to 250 horizontal scale and vertical scale is 1 is to 65. The vertical distortion is 3.8. Like that we have distorted the model and we have constructed and we have studied the model studies conducted at CWPRS and results we have got and we wrote the technical reports and submitted to the project authorities. In this, Kosi River model is still existing and Yamuna River model is also still existing with CWPRS. In vertically distorted models, there are three types of other models also there. Rigid bed models. So the bed of the river is rigid, means we have done plastering with cement plaster. So the bed movement is not allowed in this model. So this type of studies also we are conducting at CWPRS. If you know the water levels, only water levels, and this stable reach of river, studies of stable reach rivers, you can go for rigid bed model. Semi-rigid bed models, we can go for in a rigid boundary models. Material movements of local nature can be studied by reproducing desired portion with sand, sawdust, coal, dust, etc. In this one, the bed is plastered with cement plaster and some sand, sawdust we are using for bed movement. And these type of studies we are called semi-rigid bed model studies. And mobile bed models are purely the model bed is constructed with silt or sand of D50 size. Suppose Yamuna bed river bed model is constructed with D50 of 0.34 mm. So in this total model is with silt from upstream to downstream, and flow pattern is also we are every year we are uh, changing with the latest cross sections, and we are releasing the discharge from this mobile bed model. And bed movement and silt movement is also you can see in the mobile bed models. Hydraulic models. Instruments are required to obtain the necessary information from scale models. Flow velocities we can measure. Pressures, bed levels also we can measure in these physical models. The accuracy of the model results depend upon the large extent of the quality of the instrumentation. The following hydraulic parameters are normally required to be controlled observed in hydraulic scale model. Water levels and differences in water levels. Flow velocities and discharges intensities. Angular flow we can measure. Concentration, sediment concentration, and cover patterns, cover depth we can measure in the physical models. The availability of certain instruments may influence the selection of the model scales. The problem in the design of model scales. Following are the important physical laboratory equipments constraints with which also govern the final model scales. Available space and discharge. This is very important. One availability of space and discharge. So before constructing a physical or hydraulic model, everyone should know the how much space you are having in your laboratory. So horizontal length and width you have to know, and according to that only you have to select the model scale, horizontal scale and vertical scale. After reduction of by your model scale, the space which is available at your laboratory, it should be sufficient for this model construction. At the same time, discharge. The maximum discharge which is available in CWPRS is maximum 10 cusecs. We can uh, available available in CWPRS octagonal chamber. So that after reduction of discharge by your discharge scale, so it should be come within the below 10 cusecs. Then only you can get the discharge from your organization. Like that, the availability of space and discharge is also very important before the construction of hydraulic model. Availability and accuracy of prototype data. This is also very important. The data which is given by the project authority, it should be clear and without any problematic. Accuracy of the model control system. Control system is also very important. So before running the model, the control system you have to control at the downstream. Downstream, if you have any wear barrage control system, then you can reproduce in the model, so that you can control from there up to the upstream. You can maintain the level. So these control systems are also very important in the model, so that the backwater effect should not affect the your structure at that location. So backward should not be come up to your location. So your control system should be very far away from the your hydraulic structure, proposed hydraulic structure. Accuracy of model measurement systems. Accuracy is also very important. We are measuring the velocity, water levels, angular flow in models by using some instruments. So it should not be disturbance at that time. So little disturbance by air also it will affect the velocity in model. So take care should be taken while doing these measurements in model. And available experience of modeler. Example for calculation of hydraulic model. Now I will explain one example of how to scale down the river model. Here I am taking Yamuna river model. The total reach is 50 kilometer and river width is varies in 9 kilometer. And flood discharge to be considered is 7,000 to 20,000 meter cube per second. The maximum depth is varies from 8 meter to 12 meter. And river slope is 0.0004 and bed material size is D50 is equal to 0.34 mm and Manning's N is 0.02. These are the parameters of the riverbed from Palla to Jaipur. This is the reached in Delhi only. It enters in Delhi at Palla and leaves Delhi at Jaipur. The total 50-kilometer reach. The width is vary from 9 kilometer and discharge is from 7,000 to 20,000 and depth is vary from 8 to 12 meter. Slope is 0.004. D50 is 0.34 mm. So these are the parameters given by the project authority. Here you can see by using these parameters, the area we have calculated for the 7,000 cumex is 3,712 meter cube per meter square. For 20,000, 8,282 meter square. And wetted perimeter for this particular discharge is 990 meters and 1,416. And the hydraulic mean radius is 3.75, 5.84. Depth is at the particular cross section is 8.11 and 11.98 and velocity is 1.9 and 2.41. So now we have to scale down the selection of scale. Considering the space available, uh, the length scale can be anything between 1 is to 200 and 1 is to 300. The horizontal scale should be within these two range, 1 is to 200 and 1 is to 300. Utilizing the river cross section and water levels, workout area A, wetted perimeter P, hydraulic mean radius R, and tractive forces tau at two or three locations along river and for different discharges. In order to initiate bed movement at lower stages, a combination of horizontal scale 1 is to 300 and vertical scale of 1 is to 60 are suitable. How I can explain now? Here you can see this is the trial and error based method only. Two horizontal scales we have taken here 1 is to 200 and 1 is to 300 and four different discharges we have taken here and these are the tau p matlab tractive forces we have calculated the gamma rs. Gamma is unit weight of water and r value just now I explained here, even here r value wetted perimeter and s is slope. So like that for every discharge we have calculated the tau proto tau p for these four discharges and tractive forces of model. The formula is for tau p into L by d square. L is horizontal scale and d is vertical scale. By multiplying this, uh, here you can see these are the vertical scales which is suitable for construction. We can here we have taken 1 is to 40 horizontal vertical scale, 50 and 60, 70. These four uh, vertical scales we have taken and we have calculated here. So for this here model discharge also we have calculated. You can know this is a fluid number v is equal to here, v square by under root gd is equal to 1. Fluid number 1 we have taken assumed as per proto and v is equal to under root of gd comes from this equation, fluid number equation. And if you put g is equal to 1 value 9.81 everyone knows and under root g d without vertical scale. So if you substitute 60 here you can get 7.75 here. Like that q discharge you can calculate from the area into velocity. Area you can take L into D and again V you know under root D here. Like that discharge scale also we have calculated here. Length, depth and under root of D it will come 1,39,352. And this is the time scale length by velocity here. Like that, if you scale down this velocity, so for 1 is to 40 how much discharge you can get, and 1 is to 50 how much discharge you can get, 60 how much you can discharge you can get, and for 70 like that. You multiply this one with q6, you can get how many q6 you are available at your place and how much discharge is coming here. So in this case what is happening here, tractive forces, you can go here for tractive forces. The d50 model bed material is d50 is equal to 0.34. If you take this critical shear stress diagram to know the critical shear stress, if you take this 0.34 mm here, the critical shear stress will be coming 0.18 kilogram per meter square. So the critical shear stress, if you produce 0.18 kilogram per meter square, then only the bed will be moved. So like that you have to check in this table where the values are nearby this 0.18, you can adopt that scale for the design of the model. So horizontal scale is 1 is to 300 and vertical scale of, here you can see 0.12, 0.14, 0.17 and 0.20 for these discharges. And here you can, if you multiply this one with 31.314, so you can get some 4 qmax, 4 q6 like that up to 6 q6. So maximum is 10 q6. So we have adapted horizontal scale is 1 is to 300 and vertical scale is 1 is to 60 is suitable for construction of Yamuna model at CWPRS. If you want to check the bed movement also, you can derive the Froude number and Reynolds number, and here one for proto and model, and you can check by this diagram. You can, if you, the value will be above this spoon curve, then the bed will be movement. So bed in mobile bed should be move, always move. If the value is below this spoon value, then it won't move. We cannot produce turbulence to move the incipient motion in the bed material. Here you can see the sediment transport in the model. You can calculate by this diagram. Here 0.27. If you see here this Froude number, and if you take this Froude number, it will be show the flow regime will be ripple and dunes, like this diagram. It will be like this in your model. Here you can see the mobile bed model. Suppose this is the octagonal where the discharge which is circulating in CWPRS, they are releasing discharge from here. This is the starting of our model. Here we have constructed a rebar weir or flume to measure the discharge. 7,000, just now I told 7,000 to 20,000. So we are releasing the discharge from here. This is the total model from Palla to Jaipur, 50 kilometers. So this is the end of the model. This is the starting of the model. So total model is constructed in by concrete bed, and left side and right side there are brickwork, and leakages, there are no leakages in the model. The whatever discharge coming at the upstream of the model will goes to the downstream of the model. Again here one rebar weir is there. Again we are calculating the discharge here also. So releasing discharge 7,000 from here, and meanwhile there are three gauging stations in Yamuna river. Suppose at Vajrabad barrage and Indraprastha barrage and Okla barrage, the water levels also we have known at that places for particular discharges. So if we are releasing 7,000 here, we have to check here for Vajrabad that 204 level is matching or not. Again here 202 and 201 like that. We are checking at the same time at the end of the model also, we are by using Reebok weir we are again calculating the discharge. So whenever the discharge is same flowing from upstream to downstream from Pala to Jaipur is same, then only we call it is a steady state condition. The discharge is flowing from this 50 kilometers is same. Then only we are carrying studies, model studies after getting the steady state condition. Here you can see this is the bed of the model and this is the HFL. Here you can see the construction of a mobile bed model. So in ground we have the cross section which are given by the project authorities with an interval of suppose 500. We have given the levels here. So the deep channel is coming like this. So the strips, the cross section strips we have constructed like this. After that we have done plastering here for rigid bed model. Then the deep channel will come here. After that this is the shallow portion. These are the banks of the rivers. Here you can see this is the mobile bed model. After the construction of model and after giving the cross section, the silt will dump on this cross section, and by using this instrument will every time before going to studies we have to matching that will we call a Havari. By doing this one, the automatic river profile at proto will be coming here in the model. After that only we are releasing the water and we are going for studies. This is the mobile bed model, and without the studies we are doing in two stages. One is in with existing condition before construction of the structure. So what are the conditions, what are the water levels, what are the velocities, and what are the hydraulic parameters before the construction of the any structure. After that we are conducting the studies with reproduction of the structure at that particular location. Again we have conducted the studies, and all the hydraulic parameters again we have studied, and we check the difference in water levels, velocities, how much water levels and how much velocity is increased, and according to that the production works and river training works we have suggested uh, for project authority to implement on the proto. Here you can see the model study. Before you see the here you cannot see the hydraulic structure here. This is the existing condition. After that we have reproduced the bridge here, and again we studies we have conducted. These are the flow velocity. You can find out where the velocity is high by these floats. We can know the where maximum velocity will be there in this total width of the river, and these are the series of spurs. Study we have done studies in this particular model, and the hydraulic parameters like flow depth, velocity, and direction of flow we can find out in this one. And this is the Amana model. Just now explained the horizontal scale is 1 is to 300 and vertical scale is 60, and total range is from Palla to Jaipur. There are total 22 structures we have studied in this model, and there are three bridges and there are three barrages are there, and 10 railway bridges and 10 road bridges within the only 25-kilometer reach. Physical or mathematical model studies are very much necessary before any measures like bridges, barrages, protection works are undertaken to control and train the river. So before construction of any hydraulic structure, model studies are very much essential for construction of hydraulic structures. The selection of physical or mathematical model studies would be decided by availability of data, time, space, and cost. Just now I explained time, how much time you want to require. Suppose whenever project authority comes to us, they required within short period like in 6 months, then we will go for mathematical model studies. If time limit is there not there, so suppose 1 year for mathematical for physical model studies the time limit is we can take more time. So minimum 1 year is required for the physical model studies, hydraulic model study. So time is also very important. Space, availability of space is also important, and the cost. The mathematical model studies will cost around in lakhs, while in physical model studies will in crores. The model scale in physical model would be decided by availability of space and discharge. Just now explained. Calibration and validation studies should be conducted for every model before conducting the actual studies. River training works depend mainly upon the type of the river, its regime, and upon the characteristics of its flow. River training works vary from place to place and from time to time. Thank you. Any question? This is about the hydraulic or physical model studies conducted at CWPRs. Scale, how we have to choose the scale, and how we will study existing condition and with the bridge or barrage, and what are the different type of studies we are conducting in CWPRs. I will explain in next my lecture. Hmm. Hmm. बेड मटेरियल वो जो फोटो में जो रहता है उसको हमारे सभी को पॉइंट जैसा रिड्यूस करते हैं तब थ्रेशोल्ड नहीं लेते एक ही यूज करते हैं
So basically हमें क्या करना है कि शीयर क्राइटेरिया जो शेयर स्ट्रेस आएगा वो शेयर स्ट्रेस हमें देखना है क्या है अलग अलग कंडीशन में हम अलग डिस्कस करें तो अलग क्रिटिकल शेयर स्ट्रेस आएगा और हमारा जो मॉडल में क्रिटिकल शेयर स्ट्रेस डेवलप होगा उससे हमें ज्यादा आना चाहिए क्योंकि वो पार्टिकल मूव होना चाहिए तो उस हिसाब से हमें स्केल डिजाइन करना पड़ेगा क्योंकि मटेरियल अगर आपने बोला वैसे एक है तो वी हैव टू चेंज द स्केल तो सुटेबल है कि उसको क्रिटिकल शेयर स्ट्रेस से जो अचीव हो क्योंकि सबसे इंपॉर्टेंट पार्ट क्या है फिजिकल मॉडल में अगर आप मोबाइल बेट कर रहे हो तो उसमें से आपका जो पार्टिकल्स है आपने जो रिप्रोड्यूस कर रहे हैं मॉडल में उसका क्रिटिकल शेयर स्ट्रेस और प्रोटो का क्रिटिकल शेयर स्ट्रेस दोनों मैच होने चाहिए और मूवमेंट इनिशिएट होना चाहिए वो फ्लड में जो आएगा वो पार्टिकल मूव होना चाहिए अगर वो पार्टिकल मूव नहीं होता तो आपको जो मोबाइल बेट क्यों करते हैं हम इस कवरिंग पैटर्न इरोजन स्टडीज करने के लिए करते हैं अगर वो मूव नहीं होता है so very purpose what we are designing that model is defeated. So that forces has to be matched. So generally we do the calculations and I have shared with the Brahmaputra board that calculations how you measure the critical shear stresses in the model and in the proto. How this equivalence is achieved. There is another criteria, Young's criteria is there, and which we can use the scale and see whether that scale is suitable. So we use both the criteria, Shields criteria and Young. Shields is based on the what you say, Young's is based on the stream power. This is the critical shear stress criteria. These are the two main criteria we are using: stream power, critical shear stress. Both we can use and design or model operating. The main part is that the particle what we are using in the model should be able to reproduce the erosion or what phenomena we are trying to model in the model. That should be इन्होंने दिखाया है लेकिन ये बेसिकली क्या है कि शेयर स्ट्रेस निकला शेयर स्ट्रेस आपने निकाला गैमा आरएस और शेयर स्ट्रेस तो आपने निकाल लिया मॉडल में उसका स्केल है वो स्केल से हिसाब से आएगा तो बेसिकली हम क्या करते हैं मेरे पास एक्सेल शीट आई विल एक्सप्लेन यू द एक्सेल शीट तो जो हम करते हैं स्केल डिजाइन के लिए देख तो आता है मैंने मेल में तो मैं आपको एक दिखा तो हम एक सैंपल प्रोजेक्ट के लिए कैसे यूज करते हैं और वो एक्सेल शीट आई विल एक्सप्लेन वो मैं करता हूँ आपको
Thank you.